In the second part of the lecture on platforms and innovation, we're going to look at a further aspect of innovation enabled by platforms. What we're going to concentrate on is the phenomenon of collective intelligence. Platforms, as we said, are foundations that enable the aggregation of people and technologies in order to exchange information and transact. We have focused on the latter aspect, transactions. We're going to focus now on information and knowledge exchange. Once you have a large number of knowledge flows, could be between humans or between humans and computers or between computers, then you may have the emergence of collective intelligence. Collective intelligence has come to be known under many terms: crowdsourcing, the wisdom of crowds, crowd-related phenomena, etc., etc. Basically, at the core, there's the fact that crowd of individuals can solve problems, build information repositories, game or do gaming in order to resolve scientific problems, etc., etc. I've classified the information exchange leading to certain type of organizational's information effectiveness in 5 categories, which we're quickly going to examine. The first one has got to do with knowledge aggregation. A brilliant example of knowledge aggregation is Wikipedia. Wikipedia, as everybody knows, is certainly the largest encyclopedia, the largest repository of information, organized information on Earth. Wikipedia is by far and large the encyclopedia which has been published in inverted commas in more languages than any other encyclopedia. Has got more items than any other encyclopedia, and according to a number of people is actually more precise and up to date than any other encyclopedia on Earth, probably in any language. Wikipedia is an effort based on a platform. The platform provided by the Wikipedia Foundation. The basic technology is called the Wiki. The Wiki is a technology that enables volunteers to contribute information or to suggest either contribute information to already published item, or to suggest or actually publish new items about new aspects of knowledge. It's interesting that Wikipedia, as we said, is a distributed network, and the network is really a network of networks because Wikipedia per se is the collection of all the networks related to the single items. There are 100 millions of items, so between each item you can identify a network of contributors. Contributors do exchange information and discuss issues related to the specific item over a network which shadows the published information. The published item, you can access it and contribute both to the item and to the discussion behind the item. So imagine this gigantic network of networks, all based on a platform, the Wikipedia platform. Then you can describe this network of networks as the network of the single items, then nested, as we said, a platform within a platform. Nested within each item there is a network of the specialist about that platform. Just to give you an idea how staggering is the Wikipedia phenomenon, if you go to this animation and click on the URL at the bottom, you'll see the emergence of Wikipedia in the different languages over time, and the size of the circle will give you the number of items published in that language. If you click on the item, you will have information about the Wikipedia in that language. Notice that Wikipedia appears in hundreds of languages. Some of them are even dialects, And so it achieves a diversity and a size that no organized expert-based system could ever achieve. Another interesting aspect of this phenomenon of collective intelligence, where everybody contributes a bit to the whole enterprise, but each one contributes the totality of the sum of the contributions, is the analysis interpretation of large amount of data. I'm going to give you an example. The example is the Sloan Digital Sky Survey. What is it? Is it essentially a telescope based on a large view camera that has scanned the whole visible universe and has released all the information for free to anyone who's interested? Clearly, it has been a bonus to the world of free science, to the world of astronomy, but also it has done something else about collective intelligence. One specific problem that two astronomers had was to classify the entire set of galaxies. There are millions and millions of galaxies in the known universe as captured by the Sloan Digital Sky Survey. Classifying those galaxies cannot be done by computers because the shapes are fuzzy, and so it must be done by humans, but a team of astronomers would need years in order to get the job done. So two astronomers had the brilliant idea of asking volunteers to help in the classification. The classification doesn't need specific expertise about physics, astronomy, mathematics, but it requires the effort of classifying galaxies according to a set given of categories, whether they are circular, spiral, elliptical, etc. The stunning phenomenon is that hundreds of thousands of people have replied within days, and the whole enterprise was achieved in extremely short time. I'm giving you some description about this interesting phenomenon of collective intelligence in this slide. Notice 200,000 online volunteers have classified more than 150 million galaxies. This is something that defies the capability of experts to do. And notice they did it for free, but this phenomenon of collective intelligence was enabled by a platform that was set by the two experts, in this case astronomers. On top of that, users, in this case non-professional astronomers, have also discovered new types of galaxies, and an example is reported at the bottom of the table. The galaxy, the observation by a 25-year-old Dutch school teacher has been validated by the discussion by the community, and then has been accepted in the scientific literature. More details are given there. You can actually join the SDSS and contribute to astronomy. A third phenomenon related to collective intelligence is crowdsourcing, also known as the wisdom of crowds. What is the wisdom of crowds? It comes from an experiment done by British statisticians, Galton, who at the beginning of last century observed in an animal fair near Oxford a number of farmers guessing the weight of an oxen, a bull. As an aristocrat, Galton didn't believe that farmers would be able to achieve a result close to reality, but he collected the scraps of papers on which the guesses had been written. He analyzed them, and he found, to his surprise, that the crowd, meaning that the average of the guesses of the hundreds of farmers who participated in this inverted comma experiments had basically guessed the weight of the oxen with an error of 1 pound. The weight was 1,198 pounds. They got 1,197. This is absolutely stunning. The phenomenon has been repeated over and over again. And it has been captured in a book titled as The Wisdom of Crowds by James Surowiecki, who tells an endless list of examples related to the wisdom of crowds in all possible fields of human knowledge. The idea has been turned into what are known as prediction markets. Prediction markets are basically places where individuals can place bets against real or virtual money, and then the aggregation of the bets are aggregated. The average used to determine the value that clears the market between plus and minus, between losses and wins, and that value sets the reference for the betting, the further round of betting. The phenomenon now has been given rise to a whole new industry in itself, which is used in companies to assess strategic options, which is used of course in betting sites in order to bet on sporting or political events. I'm just going to give you one example. The way it works is based on certain number of conditions. The fact that the people bet individually, that basically they don't talk to each other, because the more diverse the crowd is, the better the result is. So you need high cognitive diversity. The more diverse the crowd is, of course, the better the final result. It needs to be bottom up, and it is based on the fact that each individual carries a different way of interpreting the same set of data and contributes a certain specific knowledge. For microscopic that knowledge is, when it is aggregated, it usually gets relatively close to the final result, even if individuals have very little, even zero knowledge about the phenomenon under inquiry. An interesting example of a prediction market is the Hollywood Stock Exchange. It is notoriously difficult to predict whether a movie will be successful in theaters or not. The Hollywood Stock Exchange tries to remedy to this problem. How does it work? Before a movie is launched, it appears in the Hollywood Stock Exchange, and people, volunteers, bet virtual money whether the movie will be successful or not. The aggregation of the betting gives a positive or negative result. I collected this information a couple of months ago, and you can see that certain movies were predicted to be faring pretty badly, in this case Ex Machina and the Sisterhood of Night. Others that were ready to open but not open yet. You can go and check what is the situation right now. The Hollywood Stock Exchange does pretty well, at least as compared to experts. Another interesting aspect of collective intelligence is the fact that platforms enable problem solving by a crowd of individuals. One of the types of this organizational approach based on platforms is innovation market. The best example of innovation market is Innocentive. Innocentive is a company. It was launched by pharmaceutical giant Eli Lilly, and then it was supported by Procter & Gamble and other companies. You have already read in Innocentive in the article on Connect and Develop. What is Innocentive? Innocentive is a market where tournaments are held against scientific problems. Again, not only scientific problems. How does it work? A company pays to register on Innocentive, and then can post problem. So the companies are seekers. What they seek are solutions to a certain problems. And then there is a network of hundreds of thousands of solvers, volunteers, that declare certain areas of expertise, Innocentive email them the problems relevant to their declared expertise, and then solvers can compete on the solution of problems. The problem comes with a financial reward, and then Innocentive and the company decides among the submissions which one is the winner, if there is a winner. Examples of challenges are reported on the right hand side. They can be related to technology or could be related to other aspects. Here you find further examples, and by the way, you can join right now Innocentive for free and join the network of solvers. What's interesting is that it opens up to lots of different disciplines. But what is interesting is that many problems are actually solved by experts in other disciplines. Meaning there could be a problem in finance solved by a marketing person. There could be a problem in physics solved by a chemist. There could be a problem in chemistry solved by a biologist. This is an interesting observation which has given rise to the discussion whether there are problems whose nature transcend the specific discipline. Meaning, there may be problems that have already been solved in another area, but they just under a different terminology, a different set of jargon, if you want. So what open networks based on platforms can do is to provide companies with an attempt to find whether a problem has already been solved in another area and gain that solution rather than trying to solve the problem itself. What I stress here is that, as you may have noticed when we discussed open innovation, and specifically Procter & Gamble, is that Innocentive is not an alternative to internal research and development, but it's a complementer. Companies can now decide whether to solve a certain problem via the internal route, or they may decide to use platforms such as Innocentive and access the collective intelligence to see whether certain problems have already been solved or are solvable in a faster way by the community of solvers. Another interesting aspect of collective intelligence is the fact that people can compete over platforms by around games. Now, games don't have to have only a ludic, a playful aspect. They can also be used in order to solve real problems. But to give you an idea of how powerful this technique can be, let me talk about chess. In 1999, Kasparov was at the time the world champion and probably the most important chess player ever lived, played against the world. The world was a network of volunteers who could contribute moves. The moves will be voted, will be ranked by the community of expert and non-experts, and then the most valued or the most voted move will be played against Kasparov. Noted that Kasparov had an advantage because the deliberation of the world were open, whereas of course the thinking of Kasparov was unknown. Now, Kasparov declared that it was the greatest game in the history of chess. The sheer number of ideas, the complexity and the contribution it has made to chess make it the most important game ever played. So this is another again, what you have is a platform, in this case platforms about chess playing. What the platform does is the aggregation of the intelligence of anyone who wanted to contribute, experts and non-experts, and the aggregation of those moves made the world play at least at the same level of the smartest chess player ever lived. Notice that no one in the crowd in the world was remotely close to the level of Kasparov, but the aggregation of their intelligence made a strong opponent to Kasparov. It doesn't have to be only in chess playing, but it can be also used in science. This is an example of how by devising a platform about protein folding, which is one of the greatest problems in molecular biology, a game of non-expert, in this case non-biologists, was able to find a solution of how a certain three-dimensional chain folds and solve a problem that had eluded the intelligence of the experts for a long time. Essentially, they found in a few days of playing the structure of a protein causing AIDS in a certain type of monkey. Notice in this case the collective intelligence of non-experts collaborates with the specific expertise of experts. So platforms then enable the world of expertise to open up and to profit from the intelligence of non-experts, from the collective intelligence. So this collective intelligence closes the discussion on platforms. I recap one more time that platforms are technologies that enable the aggregation of intelligence, and they enable the aggregation of transactions. Platforms are powerful because they enable the emergence of ecosystems of interdependent players. In order to understand, especially the business aspect of platforms, I'm going to upload, invite you to read the paper by Eisenman, Parker and Wallenstein about two-sided markets, and also the very short paper by Cusumano called The Evolution of Platform Thinking.